My guest today is Bo Lan.
Thank you, Tom, for inviting me to attend your interview. That's interesting to share my scientific ideas about climate change and some other related topics. So the topic of my presentation is climate change is doubtful. Green energy brings more climate change. My first major is applied physics, and then I received my degree or PhD for supply chain management. Now I'm assistant professor of supply chain management. I want to share my understanding of the real science to all the people all over the world. I want to use two stories to explain my scientific ideas. The first story is about the extinction of dinosaurs. So normally I want to ask my audience, why did dinosaurs go extinct? Tom, if you are interested, can you try to answer the question? Why did dinosaurs go extinct?
Was it because of some large event, like a huge meteor hit the Earth? I don't know.
Yep. Most people will answer in this way, okay? But for me, I think from a scientific way, a better answer would be, so what you mentioned is called the impact of asteroid, right? That's only one of the hypotheses scientists developed, okay? So that's why I want to ask this question for the first story. Too many people thought that hypothesis is correct. The impact of asteroid is the correct explanation for the extinction of dinosaurs. But the scientific way is normally scientists want to develop multiple hypotheses to explain the same event. And I hope my audience have a better understanding about the meaning of hypothesis. Hypothesis means a statement developed by scientists. This hypothesis might be correct, might be wrong. According to my experience of physics, of science, almost all theories of science are hypotheses. It's very, very, very difficult to prove a hypothesis must be correct, completely correct, never be wrong. That's very, very, very difficult. Okay, almost all theories in science, physics, chemistry, biology, they're all hypotheses. It might be correct, might be wrong. So let's see how are the multiple hypotheses exist for explanation of extinction of dinosaurs. Yes, the most famous one is called the asteroid impact event. I do not need to explain again. Almost everyone knows this asteroid hit the Earth and disasters and winters and no sunshine, a lot of animals died. That's one of the possible hypotheses. That's not the only one, not the only correct one. We don't know whether it must be correct. It's just a popular one. There are some other hypotheses to explain the extinction of dinosaurs. For example, another one is it might be caused by intense volcanic activity. There are some evidence in India, all over the world. Another hypothesis is the sea level falls. Tens of millions of years ago, the sea level fell about more than 100 meters, or it's about more than 300 feet. That changed the Earth significantly. That might be a possible reason to kill all of the dinosaurs. There are some other hypotheses, such as climate change in 65 million years ago. So what I want to say is, in science, there are many possible hypotheses to explain one event. We cannot say only one of them is correct. All others are wrong. That's very difficult. We have to learn other hypotheses and make a smart decision. Yes, just as I explained, we need to keep an open mind to other hypotheses to promote the development of science. For almost all of the science theories, hypotheses, the process is we developed one hypothesis and then another hypothesis, another one. They become better and better. That will promote the development of science. We cannot only focus on one hypothesis. That's very dangerous. Another story, similar story. If I ask everyone that, do you think the sun, planets, stars are rotating around the Earth every day? I think almost everyone will say no. The planets are rotating around the sun, right? So this question I'm asking was a famous hypothesis thousands of years ago, okay? Most people believe the sun, planets, stars are rotating around the Earth every day. Of course, we observe it, but it's just one of the hypotheses. As a matter of fact, about 600 years ago, Nicholas Copernicus developed another hypothesis. He said, we may use a heliocentric system hypothesis, means all of the planets, Earth, are rotating around the sun. So that hypothesis is better than the previous one. Okay, we all know this story. And then we have further hypothesis. That's the developing of science. Another hypothesis is later we found the sun is not the center of the universe. The sun is taking all of the solar system, rotating around the center of another greater system called Milky Way galaxy. And the Milky Way galaxy is only one of the hundreds of millions of a lot of other galaxies in the universe. So we need another hypothesis to explain the beginning of the universe. Almost everyone knows this famous theory, that's Big Bang. Again, all of the theories, they're all hypotheses. But even Big Bang is also one of the hypotheses. We cannot say Big Bang is completely correct. There's still a lot of problems for this hypothesis. We need to answer, we need to develop, we need to make it better, we need to find more evidence to develop this hypothesis. And maybe some years later, we'll develop other hypotheses, better hypotheses. So with these stories, I want all of you to understand the real meaning of science. Science is built based on a lot of hypotheses. They might be correct, they might be wrong. Maybe part of them are correct, part of them might be wrong. That's a real understanding of science, okay? I hope next time when people ask you, why did dinosaurs go extinct? You can have a better understanding. So the asteroid impact is not the only correct hypothesis. It's just one of the hypotheses, okay? So when you have a better understanding of science, there'll be better for us to develop science. We should use critical thinking to make a smart decision about the hypothesis right now. So now I want to talk about one of the famous hypotheses. It's called climate change. Almost everyone knows it's so popular. And a lot of people believe it's completely correct. But this, I want to say this understanding is wrong, okay? I'm not saying the hypothesis of climate change is wrong because I'm not a scientist of climate science, okay? I cannot develop any specific experiments to prove whether climate change hypothesis is correct or wrong. But I want everyone to know that if some people believe the hypothesis of climate change must be wrong, must be correct, completely correct. All other hypotheses must be wrong. This understanding, this attitude is wrong. It's not a scientific way, okay? So just as explained, it's just one of the hypotheses. Like all of the other topic of science, we have a lot of hypotheses to explain the same topic. We cannot only focus on one hypothesis. For example, for this hypothesis of climate change, quite some scientists doubt this hypothesis of climate change, including myself. I just give you some examples, okay, a few examples. First one, a Nobel Prize winner in physics, Dr. John Clausen, said there's no climate crisis. I think it's true because we did not find enough evidence to prove this hypothesis of climate change must be correct, or everything else, all other hypotheses must be wrong. No, we did not see such kind of enough evidence. Just like the hypothesis of asteroids impact for the extinction of dinosaurs. We don't know whether it's completely correct. We just know maybe it's correct. We should also understand some other hypotheses, okay? So climate change, this Nobel Prize winner said, I don't think so. I don't agree. And also some other scientists also disagree about global warming. And the third one, research was led by a Harvard professor, issued in 2023. The topic is something like, new studies suggest global warming could be mostly an urban problem. To summarize the research briefly, those team, more than 15 or 20 researchers, they used more than 150 years data and found very possible that the temperature measure was biased by urbanization. Urbanization means there are more and more urban areas, big cities. There's hot island effect in urban areas. Means in big cities, it's very hot, significantly than the other areas, the larger area of the rural area. If you have more measure of temperature within the urban area, then it looks like the average temperature becomes higher. The reason is the more urban area. So that's why they found it's possible the global temperature measuring might be biased by urbanization, okay? There's such kind of theories challenging this hypothesis of climate change. If we cannot prove all of those challenges are wrong, how can we believe the hypothesis of climate change must be correct? No, we cannot, okay? Unless you prove all other hypotheses are wrong, it's possible that your hypothesis is completely correct. That's very, very difficult. Another example, number 4. This research was developed by a Chinese meteorologist, Dr. Zhu, Kejun Zhu. Dr. Zhu graduated from Harvard University in 1920s. He's one of the first meteorologists in China. He was considered as the founding father of meteorology in China. Okay? He spent several decades to read a lot of ancient documents in China. And then just 2 years before he passed away, he issued this famous paper about his study for several decades, for 5,000 years of history in China. The title of his research is A Preliminary Study on the Climatic Change During the Last 5,000 Years in China. Dr. Zhu found that in the past 5,000 years, the climate in China was changing periodically, naturally. About 200 to 400 years, the climate will change. The temperature may go up 2 to 3 degrees Celsius. It's about 4 to 6 degrees Fahrenheit. And then after 240, 400 years, temperature might go down about 2 to 3 degrees Celsius or 4 to 6 degrees Fahrenheit. Let's just change periodically and naturally. This was far, far before the Industrial Revolution for human beings. You cannot say the climate change was caused by human beings. No. It was a natural process, okay? And also in his paper, he said he noticed some other independent research thousands of miles away in Iceland and Greenland. They use the snow and ice and studied the previous 10,000 years climate change. They found very similar pattern as what Dr. Zhu found. That's why Dr. Zhu said, due to the consistent results of very different independent studies. He believed it's very possible that there were similar pattern of climate change in the previous 5,000 or 10,000 years, naturally. So if you cannot prove all of these studies, which are challenging the hypothesis of climate change, we really cannot say the hypothesis of climate change must be correct. I cannot believe. Okay, I cannot believe. All scientists should not believe it. Of course, we do not have enough evidence to say that climate change or hypothesis of climate change must be correct. No, we cannot. Same for all of other hypotheses, for physics, for science. Without enough evidence, we cannot say it must be correct. We must change it. We must develop other hypotheses and double check, find more evidence. That's the correct way to develop science. Another interesting topic, a lot of people talk about, there are 97 scientists' consensus. Without any explanation, almost everyone knows this, okay? So how about this 97 scientists' consensus? And a survey said 97% of scientists agreed climate change, blah, blah, blah. So it has been challenged for years, okay? This survey, whether it's a good survey, authentic one, quite some researchers challenged. They thought it's not a good survey, okay? I just give you some example. There are a lot of other articles you can search on website challenging this survey. The first one said there are 97 consensus may not be correct, might be biased, okay? Another research said maybe the numbers on 97 is only as low as 59%, something like that. And the third one also, other researchers challenged this survey of 97%. A lot of people do not believe that's an authentic survey. And what I'm going to ask my audience is, even the survey is not biased. Okay? Right now, quite some people challenge that survey was biased, means 97% may not be correct. So let's say even if, okay, even the survey is not biased, even the number is correct. So will you completely accept a hypothesis supported by 97% of the community? Even the survey is correct. Even 97% of people believe a hypothesis. Doesn't mean you have to accept this hypothesis. Doesn't mean this hypothesis must be correct. So let me answer another question. You will know a good answer. So how about the hypothesis about the universe before Copernicus? Before Copernicus, about 100% of the people believed the sun and all planets, all stars are rotating around the Earth. So now, do you believe that hypothesis must be correct? Do you believe the sun, the planets, and all stars are all rotating around the Earth? I think almost no one will accept that hypothesis. But why not? 600 years ago, 100% of the people believe that. Why don't you believe it? Okay? Then let's go back. If 100% of people believe the hypothesis, you will not accept the hypothesis. But why only 97% people accept? Then you have to accept and believe this hypothesis, right? So I'm using the questions to challenge you that you should use your critical thinking to make a smart decision. Whether a hypothesis is correct or wrong is not based on how many people agree about that hypothesis, right? We need to find enough evidence to prove this hypothesis is correct or wrong. That's the correct scientific way to prove hypothesis. It's not based on how many people accept it, how many people agreed it. That's not the correct way to develop a scientific hypothesis, okay? similar as their development of their hypothesis of their universe, the center of their Milky Way galaxies, Big Bang. We need more and more hypotheses to be developed to explain the universe, the world, better and better. So it means we cannot only focus on one hypothesis and believe this hypothesis must be correct, always correct. All hypotheses are wrong. It almost never happened in science. We almost need to develop more and more hypotheses. Okay, we almost never focus on one hypothesis. So that's what I want to explain to you with my first story about the first part of my presentation. That means even 97% of people agreed with a hypothesis. Then does it mean it's true? The answer is no. Okay, it may not be true. It's just a type of propaganda. Okay, real science is we cannot prove whether a hypothesis is correct or wrong by how many people agreed about it. We need to find specific evidence to prove a hypothesis. Okay, if you only base on how many people agreed with the percentage, then you agree about it. That's a kind of propaganda. You should get warned. Okay, just warned about it. It's not a scientific approach. I want all of us keep our independent critical thinking rather than accept those brainwashing. Okay, those are brainwashing. That's our mind control. Okay, so keep your critical thinking. Not only focus on one hypothesis. Accept more other hypotheses, more other ideas. Then you can have a better decision. Now let me go to the second part. I want to use the second story to explain my second part. So Tom, if you are interested, would you like to answer my second question? Do you know the book of Silent Spring?
Yeah, I've heard of it for sure. Yep.
Thank you. That is good. That's good answer. I'm glad to hear about your answer. You know it. Okay. I can tell you a true story. I used to reach out to one of the federal senators and about my idea about their climate change, about their so-called green energy, wind and solar energy. And he did not have enough time, and he asked one of his assistants make a phone call with me. And that girl made a phone call to me. She's an assistant to the senator. She focused on the area of energy and environment. So I said, okay, so do you know the book of Silent Spring? She said, no. So I was surprised. Okay, if someone focused on the area of energy, environment, but he or she doesn't know the book of Silent Spring, I'm really surprised. I hope after people watch my presentation or the video, you will know the book of Silent Spring. It was written by a biologist, Rachel Carson, in 1960s. The reason for the book is when Rachel was a girl, she loved the spring and singing of birds. But when she became a biologist, suddenly she realized that there are less and less birds sang in springs in 1950 and 1960s. As a biologist, she was curious about that and she made investigation. And then she found the reason is people began to use a new chemical material called DDT. Okay, it's a famous story. DDT was invented to kill the bad insects in the field. It can increase the output of crops. So that's good to generate more yield from their agriculture. That's a good thing. But Rachel noticed the bad thing is DDT did not only kill the bad insects, it also kill birds or hurt birds' parents. So they'll also hurt the eggs from the birds. So there will be less and less of baby birds appeared. Less and less baby birds. That's why there were less and less singing in springs. So that's why Richard began to write a book named Silent Spring. Of course, if we continue to use DDT too much, then finally we may kill all birds. There will be no singing birds in springs. They'll become silent spring. After Rachel published her book, she was attacked significantly by some chemical companies. They attacked, said she was wrong, that was not correct, DDT was good, and this and that. Emphasize the good things about DDT, but avoid discuss about the bad things of DDT. Several years later, people realized that Rachel was correct. There were really a lot of bad things from DDT. DDT will harm not only birds, but also other animals and also human beings. So Rachel saved us. Later, people began to issue more regulations. Finally, DDT was almost prohibited. And her book of Silent Spring initiated the movement of environmental protection. Her book initiated the establishment of EPA of the United States. Her book let us know that all science and technologies is a double-edged sword, okay? Double-edged sword. There are always good things and bad things for science and technologies. We cannot only focus on the good things. We should know the bad things to mitigate those bad things, to protect ourselves, okay, when we use science and new technologies. So that's important for us to understand science is a double-edged sword. We should know the good things and bad things for all new science and technologies. Chemical materials, we all know that there are some good things and bad things for drugs. We should know the bad things to avoid those bad effects. Similarly, for energy resources, we know petroleum, coal, natural gas, hydropower, they all have good things and bad things. But I was surprised that I almost never see people talk about the bad thing about wind and solar energy. I was really surprised. It sounds like wind energy, solar energy, they're so good. They're always good things. They're called green energy. I said it's so-called green energy. But according to my understanding of science or physics, nothing is perfect. Science is a double-edged sword. Every science, technology has their good things and bad things. So if no one wants to talk about the bad things of the so-called green energy, then let me talk about the bad things of wind and solar energy. There's a limited time, so I'll only focus on wind energy. There will be similar effect for solar energy. Okay, so I will use some very simple concept of physics, of science. Everyone can understand with a level of, I think, middle school. That will be enough, middle school level of science. You will understand my explanation. What are the bad things of wind energy? Okay, nothing's perfect. Science is a double-edged sword. Here's my statement. Wind energy brings more climate change, okay? Why do I say this? So let me explain why. Just use a simple example. Let me explain why. Everyone can understand it. Two figures. The first one, I'm showing you a river, okay? From left-hand side to right-hand side. Here's a river. And upstream, the city A wants to get some water. That's natural, right? Get some water for drinking, growing crops for their business, plants, anything. So they got some water from the river. So how much water left for downstream cities? Of course, there will be less of water left in the river. And then there's a city B wants to get little bit more water from the river. That's okay. So city B will get more water. Then how much water left for downstreams? Of course, less water. When more and more cities get water from the river, there'll be less and less water left in the river for downstream cities. That's obvious, right? Everyone can understand. Let me give you another figure, very similar to this one. Very similar process. Downstream, less of water. So this figure, very similar to the previous one. Now it's not a flow of water, not a river, but a float of air. That's wind, okay? In the wind, upstream, the city A wants to get some energy from the wind. And they can use the laser pointer. City A can build wind farm, okay? These are wind turbine, okay? It's not so beautiful, but it's a wind turbine. There could be a number of wind turbines as a wind farm. This time, city A is not getting water from a river. It's getting energy from the wind, right? Because we will transfer the kinetic energy from the wind into electrical energy, okay? So that's the simple concept of physics. So we absorb some energy from the wind for city A, electrical energy. If from the river, city A get some water, then there will be less water left for downstream cities. Now, if city A gets some energy from wind, then how much energy will be left for downstream cities? Of course, similar answer. There will be less of energy, right? We get more and more waters from a river, there will be less and less water remain in the river. Similarly, we get more and more energy from city A, from city B, or city C. We get more and more energies out of the wind. Then how much energy will be left in the wind for downstream cities? The answer is obvious. There will be less and less energy left for downstream cities. And what would happen? What would be the consequence for this effect? The result would be, since there's less and less energy within the wind, then the speed of wind will become lower. And the capability of the wind to deliver other things will be lower. So what will be delivered by the wind? Important thing is the heat, okay? So we want wind to bring away heat from an area, to make this area cool down, right? If the wind becomes weak, there's less of energy, lower speed, and there's a less capability to bring away heat on the area. So this area cannot be cooled down, will become hotter. And similar as when you are sitting in your room, now it's spring, summer is coming. More and more people begin to use their fans in the room, okay? When your fans is rotating fast, just like the wind, a strong wind, your fans are rotating fast, strong wind bring away heat from your body. You feel yourself cool down. But if your fan rotates slower and slower, then the fan will have less and less ability to bring away heat from your body. You will feel hotter and hotter. Similar as in this figure. If there's less and less energy in the wind, less and less capability in the wind, there's a lower speed in the wind, then this area, we cannot bring away heat. We'll feel hotter and hotter in this area. So what are we doing? We are changing climate, right? Some area becomes hotter. Some area may become cool. So we are changing climate, okay? That's only the first point. Second point, what the wind is delivering. Not only delivering away heat, wind is important to deliver moisture, okay? Moisture is the vapor from water from the sea. The wind will deliver moisture to inland areas. Then we'll have rainfall, we'll have water, we can live, we can survive, we can drink, we can grow crops, okay? If there's a less and less wind, lower and lower speed of wind, weaker and weaker wind, then the capability for wind to bring moisture will become weaker and weaker. There will be less and less moistures will be brought from the sea to inland area. What will be the result? Inland area, there will be less and less moisture. There will be less and less rainfall. There will be drought. Okay? People may not have enough water to drink, may not have enough water to grow crops. There will be less yield of crops. There will be risk of famine. Okay? People will not have enough food. So what are we doing now? We are changing the wind. We are changing the way to bring away heat. Some area will become hotter. We're changing the way of wind to bring moisture. We're changing the way to bring rainfall to some areas. We're changing climate, right? So that's my explanation, just based on some simple concepts of physics. Everyone can understand. We establish more and more wind farms. We'll get more and more energy from the wind. And there will be less of wind energy, be less of delivery of heat, will be less of delivery of moisture. We are just changing climate. A lot of people said we'll use so-called green energy. We can help to stop such kind of hypothesis that climate change. But what's the really result of such kind of so-called green energy? The so-called green energy, wind energy, is bringing more climate change. Okay, I hope everyone realizes this. Nothing is perfect. Science is a double-edged sword. Wind energy, not always good. There are many bad things for wind energy. If some people do not believe my explanation, they think, well, I cannot see how the climate was changed by the wind farm. Okay, even after my explanation with such a simple concept of physics, if you still cannot believe the wind energy can change climate. Now let me explain this photo. I've shown this photo multiple times in my presentation. Now is the time to explain this photo to all of you. So what's happening in this photo? It's wind farm in Denmark, creating fog. It was taken in 2008. Okay. Someone said it very frequently can be taken for these kind of photos in the wind farms, similar as this one. It's just outside the mainland of Denmark on the sea. I hope you can see it clearly on this figure. It shows several lines of wind turbines, okay, in a wind farm on the sea. The photo was taken on an airplane. You can see that there's wind on the sea. Before the wind touched all the wind turbine, you cannot see anything. It's just wind, invisible, okay? But after their wind turbines, there are more and more fogs or more and more clouds was generated by wind turbines. So what's happened? It means wind turbines are changing climate. It's generating fogs and generating clouds. They are changing climate, okay? If after my explanation with concepts, with figures, you still did not believe wind energy can change climate. Now this photo is showing you visibly that wind turbines, wind farms, wind energy is changing climate, obviously, okay? After that, after people took those photos, some scientists began to develop research on this phenomenon, okay? This is one of them. The title of the research is Impacts of Accelerating Deployment of Offshore Wind Farms on Near Surface Climate. In 2022, scientists found evidence that, yes, the wind farms really can change climate, okay? Just as I predicted in my previous explanation. So what did these researchers talk about in their research? I just gave you a summary. Okay? I showed the link of this research and the article, the paper. The researchers showed their impact the large-scale offshore wind farms on the sea surface climate. How their wind farms are doing. They found a significant reduction in the air-sea heat fluxes. That's exactly what I explained and predicted previously, right? You get more and more energy from the wind, there will be less and less energy in the wind, lower speed, less capability to bring away heat. So that's a reduction of the heat fluxes. They found it, okay? Researchers found it. Researchers also found cooling effect of the lower atmosphere going down. Yes, that's exactly what I explained and predict previously. Get more and more energy from the wind, the cooling down effect will become weak, become lower. Okay? Some area will become hotter. It's changing climate. Third, researchers found an increase in low-level clouds. Yes, we can see in the photo. It's changing climate. It's generating clouds. Researchers also found surface winds decreased. Yes, that's just what I explained with simple concepts of physics. We get more energy from the wind. There's less of power in wind, will be less of speed of wind. Surface winds decreased. They also found an increase of 5% precipitation over the wind farm areas. Yes, that's just what I explained, what I predicted. There's a less of energy to deliver moistures to other inland areas. So naturally, the moistures has to become precipitation, become water, become rainfall in the near area around the wind farms. The more precipitation around the wind farms means there'll be less of precipitation, less of rainfall for other areas. Other areas will be less of water. We are changing climate, okay? Wind energy is changing climate, brings more climate change. After my explanation, I wish I would become another Rachel Carson, tell the true science to all others, then realize science is a double-edged sword. Nothing is perfect. All science, technologies has good things and bad things. We should know the bad things. We cannot only focus on good things, only rely on wind energy, solar energy. That's not correct. There are bad things for them, okay? And also I wish all of us would become, all of us, not only myself, would become Rachel Carson to tell the truth, the true science to others. Actions we can take. That is, we can spread my ideas to raise more public awareness about the correct attitude to understand scientific theories or hypotheses and implement new technologies. So I use two stories to explain two ideas about science. Okay, the first part, I explained that the hypothesis of science might be correct, might be wrong. In any event, we cannot only focus on one hypothesis. Very possible that there's many other hypotheses are challenging these hypotheses. It's very difficult to prove one hypothesis must be correct. All other hypotheses must be wrong. It's almost impossible. We cannot only focus on one hypothesis like climate change. We have to keep an open mind, use critical thinking to understand other hypotheses. That's the correct way to develop science. Second point, we should understand science is a thick, double-edged sword. The good things, bad things, almost all science technologies. We cannot only focus on good things of technologies, but also the bad things. Make their smart decision, mitigate the bad things. That's for the wind energy, solar energy. They are changing climate. They bring more climate change. We have to understand this to avoid that, make some mitigate actions. Okay? We cannot only focus on wind energy or solar energy. That attitude is not correct. Yes, I hope we spread the correct understanding of science, try to change the public policies to maintain a robust energy base for USA and the world. Means all of the energy sources can be used combined together. Okay, not only focus on one or two of them, such as only focus on wind or solar energy. That is not correct. There are some bad things for that. They will change the climate. Okay. Before the end, I want to emphasize several points. First, all of those are all my personal opinions. Second, I do not represent any organization. Third, I'm an independent researcher. The reason I explain these 3 points is I issued an article on a newspaper in early 2024. There's an interview between a newspaper and me about this topic, why hypotheses may not be true, why their wind energy and solar energy can bring their climate change. After the article was published, I received both positive and negative feedback. Positive, okay. Negative, some negative feedback, they said maybe Dr. Lan, whether he represents any organization or university, so that's why I want to say, no, I'm not representing any organization or university. I just represent myself. And also someone said Dr. Lan might be a fossil guy. That's why I want to say I'm an independent researcher, okay? I'm an independent researcher. I just developed this scientific idea based on my understanding of some very basic scientific concepts. Everyone should know those basic scientific concepts. You can develop the similar results as what I showed you, okay? At last, I want to let you know who inspired me to show my idea, to stand up, to show my idea of my understanding of real science. That is Jesus Christ, okay? When I read the Bible, I noticed this part, Matthew chapter 5, verse 14. Jesus said, "You are the light of the world. A city set on a hill cannot be hidden, nor do people light a lamp and put it under a basket." I completely agree. I was inspired by Jesus. That means if I know the truth of science, the real scientific understanding, I should let others know. I should not hide it. Just like if I have the light, I shall not hide it under a basket. I want to show it to all others. I've used the light of true science, shine it all over the world, okay? Let's all of us stand up, give our light, not to the people in the house, but to all the world. Tell people the true science, okay? Not the misunderstanding of science. So let me read it again to end my presentation. Matthew 5:14, Jesus said, "You are the light of the world. A city set on a hill cannot be hidden, nor do people light a lamp and put it under a basket, but on a stand, and it gives light to all in the house." That's the end of my presentation. Thank you, Tom. Thank you all of others you watch this video. Thank you.
Hopefully you have time for some questions.
Yeah, no problem.
I really need to dig into that Chinese paper that you mentioned, over 5,000 years with the climate fluctuations. Do you think that there is anything we can take from that paper to try to predict what's going to happen over the next 150 years, or are the fluctuations so unpredictable that we can't do that?
That's an interesting question. Yeah, because I think we have limited time for this interview. So I do not want to explain with too long time. Because my major is physics. I'd love to discuss about this, but that's limited time. Let's explain it as short as possible. First, this research is very interesting. Okay, very interesting. If you like, anyone can try to find it online, but I'm not sure whether you can find the English version. Of course, I can find the Chinese version. English version, I don't know. It's 1972. That result, as I told you, that his result was developed by himself within 2 to 3 decades, independently by himself. After that, he noticed some other studies thousands of miles away in Iceland and Greenland. They have very similar results from the snows and ice. They dip very deeply in Iceland and Greenland, found a similar result for previous 10,000 years. That's why I said it might be correct for all over the world. It's changing. The climate was changing naturally, periodically, go up and down. The temperature go up and down several hundred years, 200, 400 years. And at the end of his study, he noticed that since the late 19th century until the 20th century, when he wrote the paper in 1970s, he noticed the climate was changing. Looks like the Earth became warmer. That's the first part I want to say from his study. Second part I want to say is, you asked me whether we can predict the change of the climate of the Earth. I have to say the scientific way is very difficult. It's very difficult. You can just Google it. Okay, you can just Google it about the climate, the climatic science. All scientists of climate, they agree that it's so difficult to make prediction of climate. Okay, there's a famous story. I think you and a lot of others have heard the story. Said if the butterfly when its wings in the rainforest in Brazil, it may bring a tornado in America. Why? The reason is the climate system is very unstable. It's very unstable. A little bit of change, even the swing of the wing of butterfly can change the system dramatically. Unpredictable result. So that's why there's a story. It's not kidding. It's a story developed by climatic scientists. All of them believe it's almost impossible to make an accurate predict of climate. If we cannot make correct, accurate climate predict, how can we know the so-called hypothesis of climate change must be correct? It's too difficult to prove it's correct. Of course, you cannot predict it, right? It's almost impossible to make an accurate prediction. Right? It's too difficult. We have people developed very superpower computers in the recent several decades. Why? We developed very superpower computers. It can operate trillions of times per second. For our normal daily use, we'll never use such kind of supercomputers. The main reason for those supercomputers, there are two main reasons. One is for military, to predict the flight of the missiles. Second, for climate forecast, okay, for weather forecast. You can see that how difficult it is. It's too difficult to make an accurate prediction of climate change, their weather forecast. So that's why we really have to doubt the climate change hypothesis. It's too difficult to prove it's true. We should doubt it, okay?
So that Chinese paper that you mentioned, it seems like that kind of puts a kibosh on the whole handle of the hockey stick. We're supposed to think that for thousands of years, the climate was kind of level and didn't really change because CO2 didn't change. But then you're saying this study, of course, shows that it was fluctuating for thousands of years. And the whole idea that at CO2, if CO2 was pegged at 280, then the temperature was pegged at a stable temperature. Not true, right?
As a matter of fact, the paper is one of the studies challenging the hypothesis of climate change. I just showed 4 examples, right? Everyone can Google it. You can find, I think, maybe hundreds of such kind of studies, papers challenging the climate change hypothesis. So what I mentioned about the study of China is just one of them. As I told you and all others that for any hypothesis, you want to prove your hypothesis correct. It's so difficult. If you want to prove the hypothesis of climate change is true, you have to prove yourself is correct. You have to prove all other hypothesis must be wrong. It's almost impossible. Okay, in the history of physics, of science, it's almost impossible to prove yourself is completely correct. All others is wrong. Almost impossible. Just as the example from the research of China. Can you prove it's wrong? It's too difficult. It's very strong evidence to say his study, very possible is true, very possible is correct. So it's challenging the climate change hypothesis. And to prove the hypothesis of climate change, many things you have to prove. You have to prove is the climate change, the so-called climate change, must be caused by the industrial revolution of human beings. I did not see direct evidence. You have to prove the so-called global warming must be caused by the increased emission of carbon dioxide. I did not see direct evidence, but I did see some studies say the warming effect from the cloud. Okay, every day we can see many clouds. The effect of warming the Earth by cloud might be higher than carbon dioxide, 10 times, 100 times. If the effect of global warming from the clouds is much higher than the warming effect from carbon dioxide, if people really want to cool down the Earth, then they should not cut carbon dioxide. They should cut clouds. They should remove clouds, right? Why they do not remove clouds? They want to remove carbon dioxide. I really cannot understand from the perspective of science. Really doesn't make sense for science. Okay?
Okay, very good. Then you touched on this, but I'm curious that you've spoken in public a little bit about this against the narrative. And have you been facing cancellation at your university at all? Like, don't talk about this anymore, you're going to lose your job?
That's an interesting question. That's an interesting question. I think I used to ask others, and you maybe notice that when Google search it on internet, you will see some people, some researchers, they denied climate change. But if you make research with more details, you may find most of those deniers, they retired or they are going to retire. Why that happened, right? Why that happened? We can establish hypotheses to explain this strange phenomenon. Only senior people understand science. Young people do not understand science. Is that correct? I don't think this hypothesis is correct. It could be a hypothesis, but I don't think it's correct. Another possible hypothesis is, as you mentioned, that is there any cancel culture? If someone do not agree with climate change, they will be canceled. They will lose their job? Maybe, right? Maybe. So that might be one of the reasons. So I think we have to stand up to protect the freedom of speech, the freedom of science research, right? No matter on campus, in the research, in any organizations, in the public, we have to protect the freedom of speech, freedom of science. Just as I mentioned that, have to keep an open mind, accept, try to understand different hypotheses. That's the correct way to develop science. That's why I explained at the end of my presentation. I do not represent any organization, any person. I represent myself. Maybe you can consider I represent science. I love science. I love physics. I know the true science, right? We have to protect freedom of science, accept more hypotheses. We almost never focus on one hypothesis. When we read history, you will see that every time if people only focus on one hypothesis, one theory, there are always disasters, okay? We always see disasters happen. That's wrong. We have to keep an open mind, critical thinking, accept more hypotheses, different ideas of science. That's a really science. I want to repeat again, I'm not denying the hypothesis of climate change directly. I'm not a scientist of climate. I cannot design any experiment to get evidence to prove whether the hypothesis of climate change must be correct or must be wrong. I cannot. But I'm sure that the attitude to only focus on one hypothesis for climate change, that attitude is wrong. Okay? We have to have a correct, good attitude to science. Then we can develop science. Otherwise, focus on one hypothesis, one theories, it's wrong. It's dangerous.
Excellent. Well, I'm really glad that you have the courage to speak out on this. This is so important. Any other points you'd like to make before we go ahead and finish off this podcast?
No. I just hope, as I mentioned in my presentation, not only Wuhan become another Rachel Carson, but I hope all of us will become Rachel Carson. Okay, stand up, tell the truth, tell the true science to others. Okay, use your critical thinking. Everyone learned it in our schools, right? Everyone learned it in our schools, but why don't we use it? It's surprised. It's surprised. I'm surprised, right? We have to use it, critical thinking, to check different ideas, different hypotheses, and then you make decision about which one is better, which one is correct. Never only focus on this one hypothesis. It's too dangerous.
All right. Thank you for your time. I hope to have you back on here again. Olan. Talk to you next time. Goodbye.
Thank you, Tom. Bye.